Okay, we were looking at systems, right? And there's another PowerPoint out there on the lectures. And I think we got into the hydraulic section. Y'all got any questions about the pneumatic section? So we talked about multi-stage compressors. Are you okay there?
Whatever.
Multi-stage compressors. So what is a multi-stage compressor? What do we do with multi-stage? Well, we take the output of one compressor and then, yeah, we'll take the output of one compressor and then compress it again, right? So they'll have multiple cylinders on them, a reciprocating compressor, but the higher the pressure, the smaller the cylinder. The most I've ever seen is a three-stage compressor. I think this is a two-stage compressor, and you can tell the output. So these guys here, they take it out of one, they fill it to a what we call an intercooler, and then before they send it into the other, right? You understand? Because that way, if it's heated and and it's going to try to expand anyway, if you heat it and then it cools down, you're going to lose that pressure. So what they do is they cool it down and put it into the second compressor, so that way they can compress it again. Y'all understand that? So if you didn't cool it down, what would happen? It would have pressure. Yeah, but what happens when you heat a gas? Expand. Okay, so if it don't have anywhere to go, it creates pressure. So you take that thing and you heat it, and then you send it into another compressor and you compress it, then you cool it down, you're going to lose your pressure, right? You understand? Because what happens when you cool it down? It contracts, right? So they have that intercooler in there. We have multi-stage compressors. So what we do is we bring it out of the first one and we cool it down. So then we get back to what it's supposed to be, right? You understand? And then we'll put it into the second compressor and compress it forward again, right? You understand? So we have to have intercoolers on these multi-stage compressors. This is a three-stage compressor, and you can see each time the size of the cylinder keeps doing what? Getting smaller, because you're taking something that's already compressed and you want to compress it more. If you went into the same size cylinder, it would do what?
Have less pressure.
Well, it doesn't compress, right? You understand? So you put it in there, right? And you're down here, right? So on this one you're up, and then you bring it in this one. This one will be down. Well, if it has the same volume as this one over here, as soon as it goes over here, it's going to uncompress, right? You understand? And then you're going to get the same, you'll come up and get the same pressure, right? That makes sense. But if we come over there and take something that's compressed and put it in something that's got the same volume as what you compress when it's on its downstroke, then you can do what? Then you can compress it more. That makes sense.
So each time our bore diameter
Get smaller. And that's same.
Do the stroke get shorter?
No, the stroke's gonna be the same.
It's gonna stay the same.
And that's why you make a smaller, if you make a smaller bore, then you increase the volume, right? Decrease the volume. So how do we calculate volume? Well, it's the area times the length. And what we're doing is we're keeping the same length, because normally they run off the same cam. I mean, off the same crank. They run off the same crank, right? That's what and if they do that, then that means they'll have the same one. They'll have the same stroke. So we could do that because what we're trying to do is we're trying to take a smaller volume and put it into an area that it fits into, right? Or a volume that it fits into. So no, they'll all have the same stroke. Normally they run off the same prime mover, so you can see this. This would be the gearbox, and this is where the crank would be. And basically it's going to make sure when this one is up, this one's going to be down, right? Does that make sense? So when this one feeds out, it's going to feed in here. But then what we do is we get the same volume in this one when it's retracted as we did on that one when it was extended. And then if we get the same volume, then we can do what? Then we press it again. So these multi-stage compressors, every time we go to the next one, it's going to keep getting one smaller. And this is true whether it's a centrifugal compressor or whatever type of compressor it is. Even on a rotary screw compressor, if we feed it from one into another, it's going to be what? They're going to automatically be closer together. So
where are the fans? What are the intercoolers?
it's probably in here, and you got to be careful because sometimes it's kind of hidden. This one you can definitely see, right? And this is the one we looked at. This looks like this is a 6-stage compressor. I think they got 3 on this side and then 3 on that side. This on the other side is hard to see, but you do see the filter on the side. This is a 2-stage compressor, and you can really see the intercooler here. Now they're going to have fins on the tubes themselves to try to cool it down, and then they'll run it through an intercooler. This guy right here, it just might be the compressor. So you can go to Harbor Freight and you can buy a compressor, and then you come up and you hook it up onto the unit that it goes into. So I don't think this is the entire, what we call the entire compressor assembly, which would consist of the what? The tank, the reservoir, and also the intercoolers, and then the actual unit that does the compressing itself. So when you look up a compressor, you might get the whole unit, or you might just get the device that does the compressing. So that's probably what that is. Why don't we see the intercoolers? Because it's not mounted on the whole assembly, and that's just what I think. Of course, I don't know. And we looked at the different types of compressors, right? This main compressor, you're not going to run into this in hydraulics, and why is that? You'll see it in pneumatics all the time. Why won't we run into some of these in hydraulics?
That's not going to create enough. It will not create enough pressure.
Right, and the pressure's so high. So, it'd be hard for you to put a little wiper down there and not have it break. So the hydraulic compressors are going to be big boys like these guys, screw compressors, lobe compressors. What you'll find out, this guy won't be one. We definitely don't have a diaphragm compressor. And why we brought this up, because like I said, a lot of times the airbrush compressors that you buy that runs at real low pressure, like 25 to 30 psi, a lot of times they're just little diaphragm compressors. Now, this is a better view of an actual frame, an actual compressor. So I went out today and found some more stuff, and it works a lot like a jet engine. But you can see what happens. The blades get closer together, and it starts decreasing the volume as it flows through it. What's nice about these guys is they create a really constant flow, very constant. And we looked at an impeller compressor. And then I found the video for the scroll compressor, see how it works. So it just traps the fluid in between the scrolls. And then this is basically where we're at, the symbols. I think it's right here. And then aftercooler. So aftercoolers, what's the primary function of the aftercooler? So an intercooler, its primary function is to cool it down between stages. What's the function of the aftercooler? Close. What happens when we chill air that's got moisture in it? It condenses. So the main purpose of the aftercooler is to remove moisture from the air.
Does it reflect on you? If the gas condensed, might have some fuel in it. I'm just asking.
I don't know what you're I have no idea what question.
It's been done with cars. That's why I was asking you.
Okay, so what we're doing is we're using pneumatics to create a pressure and create a flow.
Okay.
So I don't know what you mean by unused. There's nothing.
Okay.
When I burn something, I might have some fuel that didn't get burned,
Right.
and I might recycle it, right? You know what I'm
Right.
saying? But here we're just creating pressure. But the problem with air, not some gases, the problem with air is that for one thing, when we compress it, it gets hot, and when it cools down, it's going to condense. And then, of course, when we compress it, it's going to release moisture anyway, right? Because it can only hold so much water per cubic foot. If we decrease the volume, then it's going to release the
But
water.
anytime we deal with aftercool, we always dealing with pneumatic.
Right. In hydraulics, we don't call them coolers, we call them radiators. So we have to cool the hydraulic fluid down too. So it works just like a radiator in a car. You know, so your radiator is basically a fluid power system, right? You know what I'm saying? Even though all it does, it don't have any actuators really, but it runs in that cycle. But then in HVAC, you know, you compress that thing. What's the first thing we need to do? We need to cool it down. You ever felt of the high pressure pipe on those things? They're what? They're hot, right? That's down there. Which one? The condenser cools it down? The evaporator, where, huh? Yeah, it releases the heat. So that's the cooler. That's your after cooler right there. I'm sorry, I don't know if that would be considered. It's only one compressor, so that would be considered an after cooler, right? So we don't have stages on that thing. Receiver, most people call it a what? Tank. And then piping. This is a system, and I found this one too. This would be and I thought this was interesting. In most industrial applications, the reservoirs are not at the compressor unit itself. They're out in the shop. So instead of trying to feed that flow all the way from the compressor, they put these big tanks out in the shop, which makes sense. I thought that was interesting. And I put this in there today, so if you're looking at the slides, and of course, we've looked at this several times, right? So this is a typical pneumatic diagram. Everybody okay there? So this is their e-stop. So these this has an e-stop on it, but what's nice about this e-stop is part of the service unit. It's actually part of the service unit. And this is the symbol for what?
Right.
Filter with a drain. This is a symbol for a it's got right here. Regulator. This is a symbol for a gauge. Yeah. And this is the cutoff, so it's kind of like ours, but this is actually an e-stop. So what happens on these stops, the way these stops are supposed to work is that when you hit them, they're supposed to latch down, right? You understand? So you can't slide them back and forth. They're supposed to latch down. And then you got to do something special to pull them back up. On those, the ones on the amateur line, when you push it in, it's got two little fins that pop out on the other side. And then and then it's got a lockout on it. So a lockout is where we can put a lock on there and a tag, right? So we don't do lockout over there. I wish we could get used to that. Because normally when we're out there in industry, when they say lockout, you're supposed to lock out all power sources. And people will go out and lock out the electrical and they forget about the water, the fluid power. Or they forget about pneumatics. So hydraulics, if you go and kill the pump, you've lost everything, right? Unless you have an accumulator. That's where you get into problems. But if you don't have an accumulator, as soon as you turn off the hydraulics, you lose your flow, you lose your pressure. But pneumatics, you go when you turn off the compressor, what happens? That tank has got all that pressure still in there, right? So you need to bleed, and that's one of the things they say, bleed off all stored power sources. If you ever look at the procedure to go out and work on something, you're supposed to bleed off stored pressure. Pneumatics is going to do what? Going to store pressure. So just about all your tanks or reservoirs have what we call safety relief valves on them. You can come in and just pull them out. You have a little ring on them, you can pop them out, and it'll drain all the pressure. Right? Or a lot of your drains, we do this a lot. A lot of your drains, you can open up the drain and bleed the pressure off there too. But everyone okay on this? Y'all understand all those symbols? So we meter in or meter out? Meter out, right? This is a symbol that this is a Ventura. This is the guy that generates we know that if you narrow the path, what happens if you send the flow through a narrow path, what happens? Speed goes up and pressure goes down. So we use these a lot to generate a vacuum. So both of our manufacturing lines over there have a vacuum on it, but we don't have a vacuum generator. They do it with this Ventura like this. Both of them. But you'll hear the pressure being exhausted anytime they use those, because that's the way to do it. It actually exhausts. So the parts of a hydraulic system, first thing we'll look at is the tank, also called the what? Reservoir. I think it's technically called a receiver, to tell you the truth. I think that slide is wrong. I think in pneumatics we call it a reservoir, or that might be opposite. We need to look at that, guys. So the reservoir side, and this is some rules of thumb, the reservoir side should hold 2 to 3 times the pump output per minute. Ensure a high enough fluid level that when all the actuators are extended or motors are running, we should put that, there's not a whirlpool in the pump circuit. That would be bad, right? Because if you see that whirlpool, what does that mean? You suck in air, right? Have enough airspace when the accumulators are retracted. It allows thermal expansion of fluid. Everybody okay there? That makes sense. Tall and narrow is preferred to wide and flat. Parts of the reservoir would be your oil level indicators, some way to fill it, some way to let it breathe. Internal access door, baffles. What's a baffle? Anybody that's ever had a water bed knows what baffles are. Well, a baffle serves basically the same thing. But what happens is that if we don't do that and we're pouring water in some side, it has a tendency to start. So used to water beds, they used to call full flow water beds, and then they call restricted flow. Well, the full flow water beds, you'd go in and flop down those suckers and they'd go, and you'd sit there the whole time. If you moved around, you'd be doing this. Well, the restricted flow had a bunch of baffles in it. So all they had was these little curtains, had all these little holes all through there. And so what would happen is the flow would have to go through those little holes, and it would prevent it from setting up that wave or that resonating with the flow. So that's all baffles are. So in the tank, it'll have these metal things coming down. They'll just have a bunch of holes in it. So when the fluid moves from the return side over to the pump side, it's going to have to flow through those baffles. And that way it don't resonate or start sloshing around inside there. Got to have a drain plug, right? And then got to have filters. A lot of times the temperature gauge is optional, but most of them I saw usually have one in there. So this is a typical reservoir. So they didn't show that. So this is your pump. This is your tank. It usually uses a sight gauge on the side. Y'all seen these sight gauges that keep up with what liquids are? So it's pretty simple sight gauge on those. So you'll know how much fluid you got in there. Hydraulic piping. So hydraulic piping, this is basically, hydraulics is an expensive system, and why is that? High pressure. High pressure means our seals and everything inside our actuators are going to have to be a lot better, right? You understand? And then plus our piping is going to have to be high pressure piping. We use a lot of metal tubing. And then maybe connecting our pump and some of our actuators that's going to be in motion. You'll see a flexible tube on it. And guess where they use the brake in that flex tube? But even on these big earth movers, you'll see that flex tube. There's a little old tiny thing on the back, and it's just enough to let the actuator do what? move when it rotates around. Pumps and motors, rotary vane pump, which I said I'd seen that. Most of our pumps, the biggest pumps that we have is these, what we call a swash pace pumps or a piston pumps. So notice this plate right here is in an angle. So what's going to happen is when we're spinning this thing around, it's going to automatically cause those pistons to move in, and that's where your inlet's going to be at. And when it spins around and starts pushing out, that's where your outlet's going to be. So this is a very popular device for extremely high pressures. And then, of course, the outside gear. This is the one we have most of in here. I think both these are outside gears. Y'all seen those, right? And those things can handle extremely high pressures. And this is an angle. So here, the swash plate is straight, and then the pistons are at an angle. So this is, you'll see this one. This one, I think this one's called a vertical piston pump or inline. I'm sorry, this would be called an inline piston pump. So here, the swash plate, which acts like the crank in a car, this is at a what? At an angle. You'll see that? And this would be an angled piston pump right here. So here, the swash plate is basically straight in line with the shaft, but here the actual pistons are in there. And sometimes, like we said, this angle could be adjusted. If they adjust that angle, then they'll be able to change the displacement, which would be able to change the flow rate, right? Let's see, that one. Accumulators, we've already talked about this. Stores pressure, pressurized hydraulic fluids. Dampens pump, pulsation, dampens hydraulic shock, and provides extra flow when needed. We talked about that. So if we use a big old accumulator, what it does, it allows us to have a pump that meets the flow of the average flow of the system, and then the accumulator will provide the extra flow for high demands, right? You know what I'm saying? So they would basically reduce the cost of the pump. And then, of course, another thing nice about accumulator is it stores pressure. So if the pump does fail, then we got a certain amount of pressure that we can do to move things out of the way and stuff like that, right? Weighted spring, piston, and load. Vertical cylinder with weight acting against the rod will maintain a constant pressure over the operating range. So these I just loaded on there. So we talked about the weight. Y'all see how that works. It's not very complicated. So basically we have a nice big piston in here, and then we got big old weights that we do what? Put on top of it. When the system's running, it'll come up here and do what? Push it up. Now it's up here in the air. And then system fails and the weight's going to return the pressure. This is a spring type. We talked about that. It works the same way. So when the pump's running, it's going to come over here and it's going to push this up against the spring. And then if the pump fails or we get a pulsation or if it needs extra flow, then the spring is going to push down. As soon as the flow comes back up, the accumulator will fill right back up, right? And this is a piston type. The piston type is also a gas type, but the gas could actually be a bladder up in here. And what we do is we basically just put some type of gas, maybe air or some other type of gas in there. And then when it moves up, what does it do? It compresses that gas. So these are the bladder types. It works basically just like the piston types. So what we got this big bladder. That we do what? So it'd be rubberized bladder, and we just fill it full of gas, and when the pressure comes up, it collapses the bladder, and then if we lose our pressure, what does it do? The bladder will push it back out. So I think this is in your textbook, right? Is that right, or did I get this from somewhere else? Six-stage operation accumulator. Accumulator is empty, no gas charge stage. Accumulator has been pre-charged with dry nitrogen. What advantage does nitrogen have over other gases? It would really surprise me. It was really surprising me. I learned that these airplanes that can fly above 10,000 feet, they don't use air in their tires.
You know, you what?
They don't use air in their tires. They use nitrogen.
Don't have moisture. Don't hold moisture.
No, that's not it.
Because it's oxygen that's thing.
Yeah.
Yeah, air expands and contracts. Nitrogen has a very small coefficient of expansion. It don't expand very much. And yeah, we got a gripe from a plane to come in and said replace the air in the tires because they got somewhere and they didn't have the nitrogen to fill the tanks up, so they had to put regular air. So when they flew back, they had to fly back. Yeah, but they had to get all the air out and repressurize them because, so when they flew back, they had to fly back under 10,000 feet, because they were scared the tires would blow up. So if they put air in there and you get up to 32,000 feet, what would the tires do? They'd blow up. Yeah. So, it was pretty interesting. Yeah. So I didn't know that before I got in there. And even then, the pressure was so high that they had to inflate them inside a cage. So they have these big old cages that come in there that put around the tires of the plane. Now we've seen some that was tore up. Luckily our plane had it was a big plane, so it had four big wheels. It had dual wheels on both main wheels.
They got slab all around them.
Oh, the scrap haulers, those wasn't airplane tires.
Right there by that side. Like a bomb.
Them things were huge. I come out of up in the Q-Bop with the electronic shops up at Q-Bop. First time I worked over there, I come trucking out of there, and I was looking at the bottom of the rim of that tire. I'm 6 foot tall. I was looking at the bottom of the rim of that tire. That's how big those tires are. You know they had a guy got killed. Worked for Uniroyal. Come out there to change the tire. They had a crane on the back of that and set it off vertical over there, and that thing fell on it. And they didn't know it. And somebody called and said, "Have you seen so and so? He hadn't made it back yet." And they went out there and that tire was laying on the ground, and sure enough, that sucker was under there. Yeah, dead. And they carried water too. They don't tell how much them things weigh. Them was some huge. Huh?
They used that because it was cheaper to buy a brand new tire.
Ours were about this big. They came about the main strut tires. The front wheel, it had double tires on the front too on the front gear, but they came up to about here on the stick. And ours was a big plane, but not like a C5. A C5 had, I guess the tires on a C5 were about the same size, but they ran, I think they ran 8 tires. I think they had 2. I think they had 4 in the front, 4 in the back. I think we could look them up. Franklin wanted to see a C5, so that was a good picture too, because they had a C5 between an F5 jet fighter and a C-130. So this is just off some compression ratios, and of course, so they say system pressure for 3,000 pounds, your bladders would have to be what? Like 1,600 psi. So it's going to be some pretty high pressure gas. It says horizontally mounted accumulator. So we don't see many of these guys. So the accumulator should be what? Vertical. Yeah, should make sense. Horizontal mounted accumulators can cause uneven bladder wear and trap fluid away from the hydraulic valve. I wish I'd have brought one of these. Most of our pressure gauges, probably even the ones we use something called a Bourdon tube. So a Bourdon tube is a hollow tube and it's flat. And it works just exactly like the things that we all played around with at birthday parties. Whistle, right? Had the spring in there, and you did what? Blow on it, and what? And you put the pressure in there, what would it do? Uncurl. So this works exactly the same way. So these are in the shape of a C, and then when you put pressure on that, even though it's metal, usually brass, then what would it do? It would try to do what? It would try to straighten out, right? And of course, the actual indicator itself, y'all can't see it, but it's right here. So when the pressure comes in, the Bourdon tube tries to straighten out, and then that's going to do what? It's going to remove this thing. And this is probably the most popular pressure indicator, is the Bourdon tube. This is the same thing. This is still, they're all Bourdon tubes. Cross-sectional view of a spring-loaded pressure gauge. So here we have a calibrated spring, and then when the pressure comes up, what's it going to do? Push the spring up. It's a calibrated spring. You know what a calibrated spring is? What is that? Pressure. Yeah, how far it'll compress with a. Yeah, so it has a precise compression ratio. It's just like at the grocery store. A lot of these vegetable scales you have are nothing but calibrated springs. So you throw your weight in there and it's calibrated, so it does what? It expands out so far before the weight. Flow meters. Now, why is it important to know the flow?
So we want to know the flow, because the flow determines the work.
Well, not the work. Well, it determines the speed, right? You understand? Of course, so if we could look at the flow with the inlet of an actuator, then we could use those formulas to calculate the speed, right? You understand? And like I said, in a hydraulic system, the flow is pretty constant. You don't get as much of a loss in a hydraulic system that you do in a pneumatic system. Cross-sectional metallic diaphragm pressure gauge. I don't know how this got over there. We do have some metallic diaphragms, by the way. I wish I'd have brought them over. We got Bourdon tubes. Usually we use these in a class. We teach a class called sensors, and we start talking about pressure sensors. We have the diaphragms. We have the Bourdon tube. I don't think we got a calibrated spring. Shock absorbers. Y'all familiar with shock absorbers, right? We've got shock absorbers on both of our manufacturing lines over there. So we got two vertical robots that move pretty fast. And then when they come and hit the stop, it's the hydraulic, so it's pneumatic. So what we do on those robots to set their position is we use what we call hard stop. So there's a lot of robots that you program with hard stop. A robot just has to be reprogrammable. So, you know what hard stops means? You know what that means? Yeah, it hits up against something. What's nice about fluid power is that we can stall fluid power. It don't hurt it. So if you ever looked at those robots over there, they're pneumatic. And it's a double acting rodless cylinders. So we push it on this side and it comes over there, and what sets where it goes over here is a variable hard stop. But we don't want it to pop up against that thing, so we have a what? We have a shock absorber over there. And what that does, it works basically like the internal cushions that we run into on our cylinders. And these guys work just like the shock absorbers in your car. So how do those work? How do the shock absorbers in your car work? Well, how does it absorb the shock? Pneumatic or hydraulic?
Spring.
Hydraulic, no. If it was a spring, you could tell people when their shock absorbers got gone. The springs are still okay, but they'll hit a bump and they'll carve it. And that's what a spring will do. A spring, when you contract it, it's going to bounce up and then it's going to sit there and do that. But it don't do that because of the shock absorber. So between that big old spring and the shock absorber, when we go over something, our tires bounce up and then they come straight back down. Why? What are shock absorbers? They're hydraulic. So what you got is you got a meter fluid in there, and when you hit that thing, the fluid is trying to get from this side to what? To the other side, but it goes to a meter valve. So you limit the flow. If you limit the flow, then you limit the what? The opposite. So that's why people say, now you can tell people usually, y'all ain't never usually when you take usually when you
It's hilarious.
usually when you take your car in, you get my wife usually takes her in and gets her oil changed. So I've never changed the oil in her van, but just about every time you take it in, they'll say your rear shocks are leaking. Usually it's not. So these are shock absorbers. So normally we put these where something's going to hit against something. So these are hydraulic. And this is just basically the way shock absorbers. These are heat exchangers. So I said radiators, but that's not what we call them. We call them heat exchangers. And what's the function of the heat exchanger? Yeah, to get the heat out of the hydraulic fluid. Just to remove the heat. This is a radiator type heat exchanger. This is just like the radiator of a car. What pressure does the car? That's not. It's got a lot of area. It does. Gets on up there. Now this is just another heat exchanger. These heat exchangers. You can see how these things work. They work just like the condenser in an air conditioner, and also the evaporator. All the evaporator is just a heat exchanger. Right? So this is the basic hydraulic system. So it's a little different than the pneumatic system. Are we okay? That makes sense? This is the basic. This is right off the test. So what's the different components here? So what's this assembled for? No. Filter. What's this assembled for? No, it's filled in. It's filled in. So this is the symbols that we use in the two trades are very, very, very similar. So these are hydraulics. This is pneumatics. So what's the difference between hydraulics and pneumatics? Yeah, so if you see the arrowhead that's shaded in is what? Hydraulic. If you see it not shaded in, it's what? Pneumatic. If it points in, it's a what? Right. If it points in, it's a... If it points out, if it points in...
I understand. I missed.
If the arrow points in, it's a...
That's the flow of the gas.
I guess you're trying to say close.
Well,
Yeah, I realize that.
Yeah.
Thank you. Y'all really surprised me. So thank you. So if the arrow points in, it's a motor. If it points out, it's either the compressor or pump. So if we see this, it means it's a what? So if I come up here and see this, what does that mean? But it's what we call a unidirectional motor. It only runs in one direction. Right? You understand? If we see them coming in both directions, it means it's a what? It's a bidirectional motor. And of course, if I come up here and do it this, it means it's a bidirectional hydraulic motor. So the symbol don't tell us what type of motor it is. It's just a generic symbol for a motor, right? You understand that? I know we've talked about that before. So this M stands for what? Yeah, but basically it's the prime mover. So it could be a combustion engine or it could be an electric motor. That's our two primary primary movers for hydraulic systems. And of course, this is the mechanical shaft. This is a hydraulic pump, unidirectional. Does not have a variable displacement on it, right? This is a what? Gauge. This is a,
That's a service unit.
no, that's not a service unit.
It's a, I want to call it.
So we don't run into these valves in a pneumatic system. So in pneumatic systems, we have a pressure regulator.
Yeah, that's a regular.
No, that's not a regulator. We don't call it.
That was my one guess.
What? That's a relief valve. Technically, it's called a pressure relief valve. Well, it can regulate, but the problem is you got hydraulics and you've got all kind of pressure. If you run the pressure too high in a hydraulic system, what's going to happen? You're going to pop seals, right? Or make them leak. You're going to have all kinds of problems. So this does regulate the pressure. So, you know, if I have this set for 3,000 PSI, it would only regulate it if this was above 3,000 PSI. But what would happen on a pressure relief valve, it's not like a safety valve. So a pressure safety valve is going to do what? It's going to dump it. You understand? So we use a lot of pressure relief valves in pneumatics. We use safety relief valve.
Safety valve, no.
Yeah.
Pressure relief valve, send it back to the.
Sends whatever's over back to the tank. So it would regulate. So if I tried to put, if I hit this end and I was trying to push that thing, if my pump had the ability to put enough flow to get up to 4,000 PSI, if it could push that hard, and that could cause problems if everything's out there. But what's going to happen is it's going to be what? It's going to be regulated at 3,000 PSI. But what it's going to do is going to take that extra flow and do what? Return it to number 8 down here, which is the what? Is the reservoir, yeah. I'm almost sure pneumatics is called a receiver. We'll double check that. This is a manual control, lever control, manual control, right? Spring center. And just about all your every 3-position valve I've ever seen is spring center. Because if you tried to center it with a lever, it just goes straight through, right? You understand? In fact, I've seen people, there was a question on the Siemens certification test that said you needed this 2-position valve, but you didn't have one. Could you replace it with this 3-position valve that you had? And sure, just take off the spring. Because it would always go what? It would go through the center. And it was a pretty interesting question. But this is a 3-position valve, right? What would we say about that valve? 4 3-way. Spring center. Yeah. We okay? What would the valve do? It's called a tandem center, right? You understand? So tandem center would lock the actuator and allow the pressure to return to tank. If this is the only actuator that we're trying to run, then this is what we would do. And that would save our pump, right? So instead of our pump trying to create flow, trying to create pressure all the time, it would automatically go back and send it back to tank. But that's why we got these different centers. And we won't have this center in pneumatics. And why is that? Yeah, we don't want to exhaust our pressure. So, of course, this dash lines indicates a pilot line, right? So this is actually pilot operated. So the pilot actually shifts it over. So if the pressure tries to go up, this pilot will cause the valve to shift over and cause it to do what? Yeah, it's going to cause it to start venting unless it drops below what the valve is set for. Sometimes these things have that on there. And anytime we see an error, it means it's what? It's variable. And that's a double action cylinder up there. Hydraulic. Are we okay? The valves, you could use a hydraulic valve in a pneumatic circuit. Everybody understand that? But you couldn't use a pneumatic valve in a hydraulic circuit. You understand why? Yeah, exactly right. That's exactly right. Are we okay? You'd probably have to lubricate the air. So we got one more thing we need to look at. It sounds like we need to look at this, and this is symbols, and then we'll be through. I didn't make any changes. So if you don't understand the symbols, you can't read the prints, right? Everybody understand that? ISO, this should be up there. So these are our what? Lines. So a solid line is a what? Main line. A dashed line, evenly spaced large dashes is a what? Pilot line. Small spaced dashes are what? Drain lines, which we'll run to in some hydraulics. There's a lot of motors like a gear motor that it's impossible to keep those things from leaking. So they actually have a place with a reservoir, and some of them you actually come in and you do what to them there once in a while, you drain. Huh? It should be smaller than the pilot line. Huh? Bigger? Yeah, but anytime you see a line coming back and going in, yeah, that can't be a drain line, right? Understand?
Yeah. Looking at
so the circles are our energy conversion. These could either be what? Pumps, compressors, or motors. And how do we distinguish those? By the arrows, right? They call it a semi-circuit actuator. We just call it a rotary actuator. We know about our control valves, right? Of course, it says measuring instrument. So what's going to be the difference between an energy conversion and a measuring instrument? Well, there is. There's got to be. Yeah, well, if I look at the basic symbols, they say energy conversion unit, and over there they say measuring unit instrument, and they're the same thing. So what's going to vary? The symbol's on the inside. That's exactly right. So a flow meter would be. In fact, I think we have them on over here. Let's go over there. Flow lines. This is where people have problems with on their drawings. So if I've got a conductor that connects, you're supposed to put a what? A dot. Yeah. If we got one that we don't put a dot, what does that mean? They don't connect. Yeah, it crosses. It's not connected. And then there's another one that's used sometimes, and that's the little loop.
That's how you got the draw taking trouble so you get draw the medic out. You want to use the little hot hole.
Now, in electronics, we tell them not to do that. You'll almost never see that used in electronics. It's the dot or not the dot. We ran into problems, and why they set these scales is that now if I need something, I print off a new copy. But when I got in the field, you didn't print off new copies; you copied what you got. Now, what would happen is that you'd start making copies of copies, and then what would happen is you would start losing lines. Lines would disappear. You can see those big old dots, And most of the time you could see where a line started, and then if you saw a dot that was aligned with it, you know you had a connection. So you had an option of doing that. But those little loops would do they would disappear. So in electronics we don't use it. Well, that's not true. You will not find a industry grade schematic that uses the little loops.
Question.
But in this class, go ahead.
Concerning the question you asked about the line, I don't know if it's gonna come up on the test or not, but there is a difference between what you have on that screen and what's in this book. So I wanna know, are you gonna honor both of them?
No, I'm gonna honor the way our prints look.
Hmm?
I'm gonna honor the way our prints look. And this question came up. I don't know where you was at, but Charles brought up the same thing. We're gonna honor what our prints look like.
Well, you said this is book for us to buy, and between these two, and looking at the print,
Yeah, I understand that.
so are you gonna honor the book? Or
I'm gonna honor what our prints look like. And I don't know where that. So if the dash line goes back to another device, it cannot be a drain line. Y'all understand? A drain line is either going to go back to the tank symbol, or it's going to go out in the air, which means you have a drain on there. Does that make sense? Yes or no?
Yeah.
So what we're saying is that there's only one book that I've ever used in my career that said exactly what I wanted it to say. It's the one I wrote. Because anytime you teach a class, you know what you need to cover. So there's never been a book that's 100% correct that I've seen. And even my book had problems in it. But this is actually a print developed by Visio and also by Fluid Sim, which we got it, but I can't install on it because we only got one key and Nancy's using it. So this is what's going to be on the field. Now, which one's bigger or which one's smaller? It's all relative to what you're talking about, but drain lines are going to be obvious. So drain lines are going to either go back to tank. First of all, we're not going to have drain lines in a pneumatic system. Everybody understand that? You don't, right? Okay. In fact, even the drain on the compressor, they don't use even, on the compressor tank, they usually don't even show that. So if this was a drain line, what would it do? Well, it's either going to go back to this symbol, by the way. By the way, this is the symbol for the what? Tank. And you'll see it. And remember, how many tanks do we have? One. So they'll do this a lot of times, and you'll see this too, where they might have a symbol of something. They'll have a symbol of something. I need to find some of those. And they'll have a symbol for something, and then they'll show this. But instead of drawing that pipe going all the way back to the tank, they go ahead and put the little tank symbol right there. But you know that pipe has to go all the way back to the tank. So you'll see them do that a lot. Why? Because that saves them a lot of drawing and a lot of piping, right? You understand? On their diagram. So anytime you see that thing, that is the tank. And the piping, it goes all the way down to that. I wish they showed that. But if it was a drain line, so some motors, you'll see that, where we'll have the symbol for motor, and then it'll come off and have this little dashed line that comes out of it, and then it'll have that right there. And that's a no pressure line, right? You understand? So it's not a pressure line because there's no pressure in a drain. And it's just in there to get that excess fluid that gets inside a lot of hydraulic motors. So it's almost impossible. You got stuff spinning and everything to get 100% seal inside. You don't even get 100% seal in your car, right? You understand that? With those rings. So there's some pressure that gets out of the top and gets into. And that's why when you pull out your engine's running, you pull it out. A lot of times you kind of feel it, right? So what size is that? Well, that's obviously a watt. I know it's not a pressure line. So it's either going to be a pilot line or it's going to be a what? Drain line. Now, how do I know this is a pilot line? So it goes back into the valve, right? You understand? So it's using that pressure to control the valve, right? You understand? So that's a pilot line. Whether it's a big size or a small size or the book's different or something like that, that's going to be the telltale sign. Because if you go by the spacing on that thing, you know, even the spacing on mine, it's basically up to the draftsperson that draws it, or the software that they use. It's depending on the software they use. So a lot of our diagrams now are drawn with a package. So we use a package called Visio that has all these symbols in there, right? And if I pull a symbol out for a pressure relief valve, it's going to have the pilot line on it, and I'm stuck with what? And fluid sim. When we pull a device in there, it's going to be obvious because the pilot lines are going to be coming into the side or from something, right, or something like that, and they're not going to be going back to tank or going out in the air. Like I said, I've seen some motors where the drain, it's actually got a drain on it. Go ahead and take a break, guys, and we'll finish this up. So these are our pumps, compressors, and motors. These are pretty simple, right? So this would be unidirectional, this would be bidirectional, this would be the variable displacement pump. This would be a variable displacement motor. This would be a bidirectional motor. No, these are pumps. No, these are motors. This would be a unidirectional pneumatics. This would be a variable pneumatic, right, or variable displacement. Are you okay? And these are our rotary actuators, which this book refers to as an oscillating motor, but I've never heard it called that. So undoubtedly, ISO refers to that as an oscillating motor, which means it don't turn, it just goes what? Back and forth. But we'll learn it. We're going to call it a rotary actuator. Like I said, these are all ISO symbols. So what that means, and that's what I was telling Franklin, what does ISO stand for? Organization. So these are actually international standards. That little book don't say international standards, so these would probably be closer to that. Then we get into our cylinders. We looked at just about all these. They have a detailed and simplified, right? We looked at both of those. Are we okay there? Yes, no. Okay, so we did talk about the double-acting, double-ended pistons, right? We talked about every one of these, I think. Cylinder with single, talk about the cushions, single cushions, double cushions, variable cushions. Now we've added something else, so we've added the magnet in there, right? Ours has that magnet in there. I wish we had time. I need to put a lab where y'all actually use those magnetic control valves that you put on your cylinders up there. And we talked about the telescoping, right? I went backwards. I think we just looked at that. These are something that we didn't talk about. We don't see it much in pneumatics, but we see it in hydraulics. and these are pressure intensifiers. So what you do is, let's say we had 1 inch. Let's say we had 6 inches over here and 3 inches over here. Well, what happens is you take that and push it, and then you would multiply it by, what did I say? 2. So what would happen is if we put 2,000 psi over here, we would have 4,000 psi over there. Right? You understand? Make sense? So we run into these in hydraulics, and that way we can create a lot of force, but our pump don't have to provide that force. We're okay with these centers, right? Or the flow paths. Everybody okay there? Yes or no? The positions, we have only two. We either have a 2-position or 3-position valve. All the valves we have in our trainer are 2-position valves. And then throttling valves, we don't cover this, but we did talk about this. So these throttling valves, these are proportional valves. So what that means is we not only control the direction, but we can also control the flow rate of that, right? So if you ever see those double lines like that, it means these are throttling valves. Non-throttle valves, 2 twos, 3 twos. Are we okay? These are all throttling valves. We're not going to deal with that very much in this class. Both symbols won't be there. Everybody okay on check valves? So what does check valves do? Well, they only let the fluid flow in one direction. These guys are even popular in electronics. We call them diodes. You ever heard of diodes? That's what they do. They only let current flow in one direction. So these are the devices we use to convert AC into DC directly. Of course, your your flow control valves, right? Everybody okay? Shuttle valve, everybody okay there? I don't have any idea what those are. Pilot operated valves, are we okay? So these we're not going, but you need to know a pilot operated valve. Are you okay there? So a lot of these we don't get into. We're not going to talk about those either. But you know about relief valves, right? Look at those. Look at those. Flow control valves, they're okay there, right? So y'all understand, so the viscosity, we do have special flow control valves. The problem with hydraulics is that when fluids start, especially oil, when they get cold, what happens? They thicken up, and then when they get hot, they're thin. The problem with a regular flow control valve is that if we use a regular flow control valve in a lot of hydraulic systems, the flow would change depending on temperature. Yeah, because if it gets cold, then the flow control is going to restrict it more because it's thicker. If it gets so these viscosity compensated valves. So what these do is they automatically adjust the flow depending on the viscosity. So if it gets thicker, it opens them up a little bit. If it gets thinner, it does what? It goes back. But the symbol's different. So these are the flow control valves. We don't have that problem in pneumatics. So you won't see these in pneumatics. You'll only see them in what? Hydraulics. And we don't need to look at those. Now, normally on our pressure sources, this is the true symbol, but most of the times that I've seen, most of the people just start it from right there. And what comes before those symbols? So what comes before those symbols? Well, if you see that symbol, it's going to be everything before that, right? So in a hydraulic system, it would be what? It would be your pressure relief valve. It would be what? Your pumps. It would be everything. But every system's got to have it. So a lot of people, you'll see this a lot. They might draw that once, and then from then on, they'll use that what? They'll use that symbol. And I think they do that on the Festo print. I think on the Festo prints, they don't even show the pressure regulator. Let's look real quick. So over here on Festo, you see what they do? So over here, so that's the manifold under there. They just put the symbol that represents the pressure source, and we know it's pneumatic, but we know there's a bunch of stuff that comes before that. We know it's got to have a shutoff valve. We know it's got to have water, a service unit. We know it's got to have a pressure regulator. We know all that's in front of it, but they say, okay, if you know that's there, then I don't have to do it what? Every time. But when you look at the Amatro prints, they show the pressure relief valve and they show the cutoff valve every time. So it all depends. So. But it's still drawn the way. I think I showed y'all the Festo valve. The manifold on the Festo valve is really, really neat. What they do is the valves are little tiny things, and then they clamp it between the manifolds. So the manifold's on both sides, which is pretty neat, instead of the manifold being under the bottom. And they literally route this through the valve. So the valves themselves are the manifolds. So they route the air through all the valves in the center. What's nice about that is that you basically can have a lot of number of valves, and you don't have to buy a manifold that supports so many valves, right? You understand? Now, sometimes they do that where the manifolds can actually be expanded. I think we might have some of those over there, but we'd have to look at them. So these are the Festo manifolds right here. The valves are actually clamped between the two. So guys, I think that's it. Let's look. Oh, tanks, and accumulators, okay? Vented reservoir, most of the reservoirs I've seen are vented. Reservoir within it pipe above the fluid level, reservoir within it pipe below the fluid level. Usually your pressure pipe or your is going to be down at the bottom of the tank, right? Does that make sense? A lot of times the return, I've seen the return come in like this, and actually it comes in, it comes back and it actually drops through a strainer. Gets rid of a lot of stuff. And these are our accumulators, right? Are we okay? In fact, I need to bring these symbols over there, so I don't think they showed the symbols. So this would be a gas accumulator, gas loaded, spring loaded, and weight loaded. Are y'all okay on those now? Are they okay? I don't know if they have those symbols in your booklet. Filter, strainer, we don't worry about heaters, gas conditioning. So what is these symbols right here? This would be your what? Filter. This is your pressure regulator. It don't look like it's variable. This would be your, this would be your, ours don't have that. What? Sorry. My screen's about lubricator. So most pneumatic systems deliberately have a little sprayer on there, and it deliberately, every time you use it, it puts a little oil in the air. Of course, if you're into painting, you don't have a lubricator. Ours don't have a lubricator because we have what they call self-lubricating valves. The Festo valves that we have are self-lubricating. So all the seals in there are probably made out of Teflon instead of other. But most of your pneumatic systems, like for our robot, when they sent us the big fan, we got two big robots over there. One that was donated from Mercedes when they changed from Fanucs over to KUKA robot, and they got the big service units on there. They handle some air, and every one of those had lubricators. And we got two robots that a company up in Huntsville put together for us, two workstations, and they didn't put self-lubricating valves in. So that's what happens every once in a while. They get stuck. All we have to do is not take them far.
So why they didn't?
Because you can't get air into the spool. If you don't move air through the spool, you can't get air to the spool.
Why they did fix that?
We didn't know it when we bought them, but all of a sudden the gripper stopped working. And it had solenoids on it, and they had light indicators on it that showed you that it was getting from the controller was trying to shift the spool, but the spool wouldn't shift. So we took them apart and we lubricated them. We got some inline lubricators. They're little old tiny things, but we're gonna have to cut our hose and put clamps on it and clamp it in there. So we'll get around to it one day. So usually, if we let them sit over there, if we don't teach our robotics class, like one semester, you go over there and there's two robots where the gripper won't work. It's just because of the valve.
How hard would it be to replace those valves?
It wouldn't be hard at all, but we just regular valves. We had the valve. The solenoids went out on the valves inside the Fanuc robot, and that little valve, it's a little old tiny thing, was $100. So why don't we replace it? Yeah. So this is your flow meter. So you need so everybody okay? A thermometer we haven't looked at, but it's pretty obvious. So a thermometer looks like a wall thermometer. We're all familiar with the pressure gauge. The flow meter, which we haven't seen before, it kind of looks like a flow control valve, but it's inside that circle. So that's pretty easy to keep up with, right? And then our operators, I'll do real good on those operators. Well, I don't know. Some of y'all are missing out on these. And the problem is that we went over the first night of class and let y'all look at the valve that had the solenoid operating on. So with solenoids, what we do is we shift that spool in there with solenoids, right? So we turn it over to electricity. When we turn it over to electricity, what can we do with electricity? To control it. So now we can turn it over to a computer, right? So this is where automation comes into play, where you can use this fluid power instead of somebody going out there moving these handles or pressing these buttons, then solenoids can move those things around. And unfortunately, we didn't have enough money. We can buy the solenoid package for this, but I was explaining that to Franklin. There's actually 4 kits that you can buy, and that's the 101, the 102, and the 103, and the 104. And of course, we just didn't have a lot of money, So it's good enough. It's good enough for this class. Just as long as you understand these solenoid operators, that kind of stuff. More and more valves are going to this guy right here. A lot of pneumatic valves that are doing that. The problem we have with pneumatics valves is the pressure is so low. So over there we're dealing with what? 50 psi. Solenoids can't generate a lot of force. Now they're good in your actuators, but they can't generate a lot of force. So what we do is we have what we call a solenoid pilot operated valve. So you got a little solenoid in there that opens up a pressure port, and then it leaves that pressure off and does what? Uses the actual available pressure to shift the spool. You see this a lot in pneumatic. Every valve that we got over there on our robot is pilot system. You understand how that works? Yes or no? I think I put a picture up here before. So what happens is over here you got the spool down here that's shifting about, and it's actually routing the fluid. And then what you got is you got your pressure coming in. What they do is they take a little old tiny pilot valve and they run it over here, and then we have a little solenoid valve over here. So I can't draw it, but it would just be a little solenoid valve. And what we can either do is block it off or do what? Let it go through. So what happens is I shift that solenoid, it shifts it down to here, then it uses the pressure coming from the system to do what? Shift the spool. And we see this a lot in pneumatic valves and big hydraulic valves. But on on hydraulic valves, you're dealing with so much pressure, it'll actually use a true directional control valve to shift the big valve. I think I showed y'all that over there, right? With the solenoid pilot operated. Well, the valve actually mounts on top of that. Usually on a pneumatic valve, you can't really tell because it's all in control. But you should be able to see it on the symbol. They should give you that on the symbol. That's the pretty stuff. Oh, I got this right here. That's what this is right here. So they're showing you it's got a solenoid, but then it says solenoid pilot operated, right? You understand? So all the solenoid does is open up that little valve inside there, and all it is just a two-position valve, right? You understand? That does what? It's usually just a little plunger that it pulls it out, routes the pressure coming in from the source, uses that to push the spool. So we run into, like I said, all the valves we have on our robots over there are all this. You can see every one of these are done that. And if I look at the Amatrol line, which I should have looked those. Whichever module we want. So they call it. So see every one of them. No, they don't show that on here. They show these are strictly what? They show these as strictly solenoid. I was wrong. But all the hydraulic cylinders use those pilot assisted. Are we okay? Yes or no? That's it, guys. So I got